Good morning to some, good afternoon to others, maybe good evening to others. Welcome to another episode of Do Your Own Research, our joint initiative between the Defiant and the Initiative for Cryptocurrencies and Contracts, IC3. Pretty exciting panel on today. So we're going to be talking about cryptocurrencies and AI, the intersection, the hype, the buzzwords, what's going on, what should we be aware of, and everything in between. I'm joined today by Professor Ari Juels, Chief Scientist at Chainlink Labs and Professor at Cornell. I'm also joined by Professor Farinaz Koushanfar, Professor at the University of San Diego, Electrical and Computer Engineering. And we're missing our fourth leg of the table, Yorke Rhodes, who should be with us momentarily, hopefully. I think he just jumped on, so we'll add him on stage. Yorke, I was literally just introducing you. Thanks for coming on. Co-founder of blockchain at Microsoft and adjunct professor at NYU. So just to get the ball rolling, kick off this conversation, Farinaz, I'd love to start with you. If you could just give us sort of your perspective on why you're interested in the intersection between crypto and AI.
I guess like many other industries, the crypto is also going through a transformative time because of the advent of the exciting technologies that are making new capabilities due to AI. But there's also a good amount of automation that needs to be done in the space of the crypto. And I think, that's what kind of makes it very exciting. Obviously, the more there's a lot of data going on in the crypto domain, and anytime there's data, there's a gold mine for AI, because we can do several types of analysis, develop new algorithm, but also that gives us capabilities for doing mining and in a better way, fraud detection. A lot of automation going on. We're really at the brink of the automation revolution, and I don't think cryptocurrency is any different than many other industries that are going through that transformation.
Would you agree, Ari? Or is there anything else there that has you sort of buzzing about these two industries coalescing?
Yeah, I fully agree. I'm particularly interested in the ways that AI can enhance the capabilities of smart contracts. I mean, smart contracts on their own already do something pretty remarkable, which is to enforce agreements between and among users in an automated and open and trustworthy way, right? And they avoid the sort of fragile, high-touch relationships that, for the most part, we depend upon in the real world. So all of that is great, except that they're written in code in a rigid way today, and that greatly limits their capabilities. It limits their ability to interface with human beings and human institutions. And broadly speaking, what AI, machine learning can bring to smart contracts is the ability to create a bridge between this domain of code-enforced agreements and the institutions that we as human beings have built and are accustomed to interacting with on a daily basis. So it's that conjunction that I, at least personally, am particularly interested in. But as Farinaz suggested, there are lots of other ways that AI can be transformative for the industry.
Yorke, would you like to jump in here with, I saw you nodding a little bit there, with anything that that you'd like to add on? Go ahead.
So Ari pointed out, I think one of the really key advantages of using AI as an attachment mechanism to interface with what normally would be very rigid. That's essentially what APIs are, right? And different types of interconnections between systems, they're rigid, right? They're very structured. By leveraging AI as a tool in a tech stack where you have that rigidity, you create a tremendous amount of flexibility. And we see that in our work that we're doing today in the blockchain space, where integration efforts into a hard-coded API tech stack that could sit on top of blockchain or interface with other technologies just takes companies a lot of time to do that integration work. And so I think that's a classic example where AI will enhance not just blockchain, but also all other very rigid interfaces. That's pretty exciting as well, because if you layer on all of the language knowledge behind generative AI, now you've got effectively interface that can understand any language, not just programming language, but any human language as a mechanism to facilitate, those interconnections. I would add on top of that where we are in AI broadly in the tech stack and in the developer industry is we're just scratching the surface. There is very little broad awareness, similar to in the year 2001, when people had little broad awareness about what could be done with the tech stack of the internet. And so I always like to remind people of that this is a pretty exciting time because the power keeps increasing in both Web3 and crypto and AI, and they're now parts of a new tech stack that we have no idea what will be imagined over the next 10 to 15 years.
Do you think that the projects that don't integrate AI into their tech stacks, like cryptocurrency projects, are going to be eventually left behind, or there's always going to be some space where tech stacks won't really require these types of tools to be integrated? Yorke, I'm sorry, I should have.
Sure. Well, I think these types of innovations with new technologies are not new, right? So we can look at what's happened in the past. That's why I referenced sort of the post.com bust era, which was a new era of building with new tools. And that's where we are today. And so we will see eventually that every single application is incorporating various types of AI into the things that they're doing. It does take time, obviously, for those older applications to be augmented and the new applications to be envisioned. But the amount of landscape here is very broad. And the types of different things that you can do that are so much more efficient, leveraging different size language models, is something that no startup is going to ignore. So,
Ari, you tweeted yesterday when we were promoting this panel that there's a big sort of intersection of buzzwords when it comes to crypto and AI. The sort of buzzword bingo. What are the main keywords, or what are the buzzwords that users should be sort of, I'm not going to say fearful of because that's too strong of a word, but aware of when it comes to projects that are promoting the use of AI in their tech stacks, projects that are actually implementing them versus the ones that are simply using it to attract more users or investors? If you could sort of peel away the layers for people that are like just starting to look into all this ecosystem and aren't really too sure of, what projects are actually doing stuff with some sort of technical promise or some seriousness to it.
Yeah, it's hard to say. It's early days, but I do think it's important for people to be aware at least of some of the common claims about the things that blockchains and AI can do together that, at least to me, seem dubious or even nonsensical. And an example would be the ability of blockchains to enable us to distinguish between generative AI content and human-produced content. I see this claim quite frequently, and it really doesn't stand up well to scrutiny, I think. Blockchains can help maybe a little bit with this problem, but not tremendously, right? So for example, suppose somebody shows you an image, a purported photograph, say, of the Loch Ness Monster smiling and waving at the camera, right? How do you know whether this thing is real? Okay, somebody could put it on a blockchain that doesn't tell you that the image is real. If the New York Times has registered on the blockchain, maybe that gives the image some more credibility, but it then gains credibility because of the fact that it was posted by the New York Times, and the New York Times could have posted it through some other reliable channel. And it's the reputation of the New York Times that is causing you to believe this thing is real. Posting it to a blockchain does give you the ability to timestamp the photo. You know that it was produced at least before the time that it was registered on the blockchain. But it doesn't give you the ability to determine whether the Loch Ness Monster was actually smiling at the camera woman or cameraman or whatever. So again, blockchains don't solve this problem directly. There are emerging solutions. For example, high-end cameras of the type used by photojournalists are increasingly incorporating something called content credentials, which produce digital signatures on photographs. A solution like that can help, but that's independent of a blockchain. And I think even digital signatures on photographs are not going to be sufficient to have high confidence in them, because we don't know how tamper resistant these cameras are. We don't know that people are taking photos of the Loch Ness Monster and so on and so forth, right? So this is an example of the type of claim that bubbles up as a result of enthusiasm around the conjunction of these two technologies, and one that deserves more scrutiny. There are plenty of others, but I think that's a good example.
Farinaz, how do you see sort of challenges when it comes to integrating AI into crypto? Like tagging on to what Ari was saying, this sort of, do you see there's a use case, for example, for AI to help in the verification process of certain information that might be inscribed in blockchain? Or do you see them as adding on to the challenge of verifying that the content was real and isn't real? Where are you sort of pausing most when you're seeing these integrations happen?
I think, AI by itself is not like just a security technology. It is an assistive technology. So you could actually think of it as a double-edged sword. It could help and it could also hurt at the same time. It really depends on who has this tool and how they're envisioning to use it. So I guess, I would go a little sideways saying, it really also depends on the use case of AI that we are talking in the blockchain. For example, if you're talking about generating smart contracts using AI assistive tools, then obviously the same way those smart contracts need to be verified, the AI generated ones need to be verified too. So it adds to what you were doing before, but you could actually also think of AI as an assistive technology, for example, for various types of fraud detection, because you give it patterns of various frauds, and then you try to automate the process. Then, of course, it's helping the process. And large language models are very capable. They're very capable in generation. They're very capable also in modeling and detection. So really, it depends on what use case we have and how we are using AI as an assistive technology in that particular use case. That will determine, is AI more useful or is it not as useful? But generally speaking, the more complex you make a system, the more attacks you could introduce. Because AI by itself is also an automated tool. It's not completely supervised, or oftentimes the newer models are not completely even explained. So that by itself generates a host of vulnerabilities that may not have been foreseen before. So it really depends on what use cases we are talking about and how we are using AI in that particular use case to say if this is actually adding to what we have in terms of security and robustness of the system, or it's like something that is actually adding to the complications of the system and needs to be verified by itself.
I'd like to press on something that you just said right there, which is the idea of supervising AI. Like the crypto industry is not very, but there are pockets that are anti-regulation, or there are pockets that are always advocating for different sorts of regulation that already exists. There's a lot of chatter about how AI should be regulated, what sort of supervision, if there should be some sort of international body that oversees it. This continues to be a very nascent technology. These are very early days. But I'd like to press on what you were saying about the idea of supervising. And if you had any ideas on what sort of sound regulation should exist when it comes to AI, especially intertwined with the technology that's also in its very early days, also has regulation that is sort of up in the air, very region specific, and is sort of this continual wild west or dark horse of an industry.
Yeah, I guess as you have mentioned, we're in the formational stages of both technologies in terms of, especially in terms of the ruling and laws that goes along with what they can do. And in particular, both of them are kind of an open-ended, because there's a lot of distributed data that gets fed in, both in terms of building models, both in terms of I guess the whole promise of the cryptocurrency has been this democratization of finances and decentralization, but it's all is really up in the air. We have to first come up with really good definitions for each of these terms, and I unfortunately don't think even solid definitions exist. And this is actually something that we have discussed with Ari in terms of how centralized is centralized, what are good metrics to measure either centralization versus democratization. And just AI is its own vast space. Obviously it is on the top of the research agenda. It was one of the big topics that was introduced by Biden in his Act for AI Act, in terms of what are the laws and policies that has to go with it. But I think it's really one could argue for pro or against any of the issues that arise there. For example, there is a lot of open foundation models, there are closed foundation models, and then there is this constant debate. I mean, there's more and more move towards open ones, but the proponents of closed ones are saying that they don't want this to be leveraged or to be exploited for other things. So as we go forward, hopefully things will clear up. I myself am a big proponent of open sourcing and having transparency, but I could see the argument from the other side, how others can see that, and how this can be a double-edged sword.
And maybe I could add. Sorry, go ahead, Yorke.
No, I was going to say related to the problem statement, which you opened the question with. I think we vastly overgeneralize what a cryptocurrency is and what the capabilities are and what the characteristics are of those things. And we do the same thing in AI, right? People think about the latest, greatest, most powerful version of generative AI when they talk about AI. And both of those things lead you down the wrong path when you're trying to put controls around things, because the controls are very pointed, simple things, the right types of controls. And so I think that's a mistake that happens when people sort of look at, what are we trying to do and what are we trying to regulate? What are we trying to control? What safety boundaries are we putting around these things that are highly complex, right? With many different characteristics.
I just wanted to add that even before we think about legal or regulatory ways of dealing with the failings of AI or ML models, we need technical mechanisms in place, because a fundamental problem with machine learning models is their tendency to hallucinate and their vulnerability to adversarial examples. Right? Hallucination means basically the model just makes stuff up. Adversarial example is an input created by an adversary specifically to induce an erroneous output from the model. Right? To attack.
Sorry, maybe just add an adjective in there, which is generative AI models.
Generative AI models, to be more precise. Although other models are subject to adversarial examples as well, right? I think the concerns that are probably of interest in the panel indeed involve generative AI models. But these two problems are fundamental, right? We're not going to get away from this, these issues in the types of AI that we want to couple with smart contracts or other crypto systems. And so, as I said, I think we need technical mechanisms to deal with them. When it comes to hallucinations, and this is a very general problem that the AI community is having to grapple with in many contexts. And this is not something that the crypto community in particular is likely to assume the burden of solving, right? And it may be that we never fully get away from hallucinations and generative AI models. And the problem of adversarial examples also seems to be a pretty intractable one. Mm-hmm. So when we incorporate these things into crypto systems, we need to have in place some technical mechanism or institutional mechanism for dealing with the errors produced by these models. And that may mean, for instance, the ability to appeal the outputs of these systems when they prove erroneous. So for instance, if there's a smart contract that says that I'm entitled to receive insurance compensation because, say, my flight was delayed. I purchased some flight insurance, and I submit documentation to show that my flight was sufficiently delayed. And it turns out that I crafted that documentation in a way that fools, say, an LLM, right? I create an adversarial input to an LLM in order to get me compensation that I'm not entitled to. It should be that the insurer has some way of countermanding the decision made by the LLM and ultimately by the smart contract. So we need to, as I said, have technical mitigations in place to deal with these two issues, even before regulation comes into play.
Totally agree. Yeah. And I think, like, if you look at what a generative AI model is doing, it's creating a probabilistic output based on a sequence of words. And so in a text context, and that's where these things go wrong. And if you look at using it in a prescriptive way where you want definitive output, you have to constrain the thinking of how it does probabilistic outputs very specifically, or else you'll get wildly different formatting outputs. That's just a very simple example that a lot of people have seen, right? Trying to get consistent output. And that's where you add in different types of resource or RAGs, which sometimes called, which help you constrain output, for example. So you can get more consistency in the models. I think the other problem with what we've seen in sort of the inference of fraud in supply chains, for example, is that these AI systems tend to create massive amounts of noise through false positives. And so it becomes also really hard to have humans then weed through the massive amount of noise that was created through false positives to then figure out how to constrain the models to get to a better output. We've seen that in a non-crypto space, but that'll apply anywhere.
Could you expand a little bit more on sort of, because so we took a short dive into the technical mechanisms, but how about institutional mechanisms? What are the mechanisms that exist there? What sort of institutions might get involved, or are we already seeing that are trying to mitigate some of these technical or adversarial issues, hallucinations? If we could expand a little bit more on the institution side of things.
Yeah, I mean, I'll take a quick swag at that. I mean, certainly from a Microsoft perspective, we have a responsible AI group. We do all kinds of adversarial attack vectors when we're building models, there's a process associated with it, right? And that's trying to be a responsible actor in the best way possible with new technology. We do that across all parts of our business as well. I think it gets hard, when you have closed models, just like it's hard when you have people using cryptography that's not open source, right? You don't know what's going on inside. And so that certainly is a concern. So I think we'll probably see, it feels to me like we'll see a push towards more open models because of that. But those are just a couple data points.
So there is, I guess, a lot of governing bodies that are emerging. For example, NIST, National Institute of Standards, has a working group on U.S. Artificial Intelligence Safety Institute, which they call. And there are hundreds of organizations that are members of that group. And they're really trying to work together to define what would be the standards for the industry and what are some of these issues. And the issues are huge. It's not really, I don't think, it can be discussed in a panel or can be even addressed by one body or one organization, which is why I think, the involvement of an organization like NIST is really crucial, because they can get together the perspectives of multiple industries and multiple open source organizations, academics, regular people, to try to come up with regulations. But these are going to help, but I think we will always be in some sort of a gray zone, no matter what we do, because on the one hand, if you put more regulations on what the outputs will look like or how you constrain your model, then you will get very predictive outputs, but it could actually limit the capabilities of the model. At the end of the day, these models are performing so well because they have if you look into even the parameter space of these models, there are billions of parameters. And this billions of parameters is really memorizing a lot of things that are happening in the system. And when you're memorizing, what happens is that there's a lot of data that can come in, and it may be junk data, but it's junk in. It becomes junk in, junk out, or it becomes a hallucination. Now there are recent work on self-poisoning attacks when these models, there's a lot of debate about the data that is being generated is getting added to what has been there before. And in a few years, we will have a lot more synthetic data than actual data. And now, so you're basically going through like a self-poisoning scenario if you have vulnerabilities, if you have wrong information. So this is really a huge number of issues that are arising because of these models, because of the power they have, and part of the reason they're performing so well is because of that power and because they're memorizing so many things. For example, language translation has never been possible in terms that have been possible today, because, or even, if you talk about cryptocurrency, if you have a smart contract, like, Ari was mentioning earlier, and you want to tie it to a particular application using like a large language model or a translation of what it should have done and what it is doing, then all these this amazing capability to learn a huge dictionary and being able to translate all these corner cases is super helpful. But at the same time, if you constrain it, you will lose some of those capabilities. So
Yeah.
it's really like always going to be in a gray zone of usability versus kind of robustness and security.
Yeah, just really quickly, a quick data point. Microsoft has built something called a Phi model. It's an open source model that we published from our research group. And we specifically only train it on textbook data to avoid the whole of internet problem, which also I think addresses the not training on generative data as well, which is interesting. And these models actually rival, at this point, the Phi 3.5 model actually rivals GPT 3.5. And so that's really interesting. I think that will probably continue as a trend, that the smaller language models that aren't trained on the whole internet actually can start to rival some of the capabilities of the more powerful models that are actually sucking up all of the data of the internet.
To talk a little bit more, Pedro, about address your question about sort of institutional support for the use of machine learning models in crypto. There may be special requirements for crypto and for smart contracts in particular that necessitate new forms of oversight or new standards. For example, the non-determinism of these models, right? They ingest seeds that in certain services are not, most services are not made available to the user of the model. So the behavior of the model is non-deterministic in the view of the user. And there are subtle issues like the non-determinism introduced by floating point computations. These are things at odds with the ethos of transparency in most of the use cases that the crypto community is accustomed to. So we may need to think about standards that give users more control of these models and limit or eliminate non-determinism in at least certain situations.
Yeah, I think you raise a good point. And I think that, and tagging on to that, I think we all agree that there should be, or that in crypto at least, there's a consensus about open source being the inherent premise on which most of these protocols are built. And are you guys seeing that that's also cascading, or that's also a sort of undercurrent in the AI space? Or is it continuing to be mostly closed source, and then you have these small pockets of open source AI models that are starting to pop up, but not as widely used as they should be used? So I just think of like Meta's Llama 3.1, and then what you're saying, Yorke, about your open source models. Like, are those sort of just one in a million? Or are we seeing a sustained trend and a sustained demand from companies, from users, from builders, looking for more open source models that might be more attuned to sort of this crypto ethos of things should be open source, there should be transparency, there should be verifiability, auditability in the code base that's underwriting all of this? That's an open question for whoever wants to take it and run.
Yeah, I haven't looked specifically at research that would drive you one way or the other there, but I do think because of the generative qualities of AI models, it's a little bit different than things that are more definitive, like, for example, an encryption algorithm. But I think the same similar principles apply, where you want to have some kind of verifiability about how do you know that a system was trained in a specific way to get to a specific output. And I do think that's where either provenance techniques or provable techniques that may not under or reveal underlying data are useful, and that also comes into various cryptographic techniques in the either FHE or zero knowledge proof area. So I think there's I don't have a specific answer. I haven't, and maybe Ari or Faraz have looked at research in that category. I think that what you see in the market is pretty sizable usage of both open and closed.
Ari, you've written a few op-eds about the intersection of blockchain and AI, and there's one narrative that stuck out because it's something that I think is really interesting, and that there's a sort of pervading idea that privacy online doesn't exist, and there's a few privacy protocols trying to address it. What Yorke was saying with fully homomorphic encryption or ZK proofs. Where's the intersection there? How is the combination of blockchain and AI in the privacy realm of things? Are they inherently going to sort of expand that problem? Or are they both a potential solution to it? Are they going to sort of maintain the status quo of how things are operating and it's going to be a non-topic? What have you discovered?
Well, I think Web3 has advanced certain privacy technologies that can be useful in the training of models and in sourcing data in a confidentiality preserving and authenticity preserving way. So for example, privacy preserving Oracle systems give us the ability to input data into federated learning systems, which provide confidentiality for data pooled from a number of different entities. They enable data to be imported into these systems in ways that protect the users or institutions that are providing the data and ensure that the source of the data is properly authenticated. Right? So, as was suggested earlier, we're kind of running out of data with which to train generative models. We have only one internet, but we have only one surface internet, and much of the deep web has not yet been exploited. So one project that, in fact, Farinaz and I have recently launched involves the use of privacy-preserving Oracle systems designed for blockchains to source data from the deep web in a manner that is indeed going to ensure that it comes from a reliable source and that the data is at least protected in an end-to-end way. Right? Whether it can be extracted from a model, of course, depends upon how the model is trained and deployed. And there is a considerable research looking at extracting training data from models. But this is a separate problem. The use of privacy-preserving oracles at least ensures that we can get data into a federated model in a way that is going to protect it appropriately, and now enables us to tap this hitherto untapped and pretty vast source of data, namely the deep web. And some of the, cryptography is useful here. Zero knowledge proofs can come into play in privacy preserving Oracle systems. So can trusted execution environments, which are typically more performant than cryptographic tools, but come with their own caveats.
Yeah, so I guess to add on, as Ari mentioned, and I guess also to address what Yorke was asking, both Ari and I have active research in privacy-preserving computing and its use cases for sourcing trustworthy data. But one thing I wanted to add to what Ari was mentioning, or not add, but clarify that even though these extracting these trustworthy data is reliant on Web3 type of platforms, the use cases are not just Web3. the use cases are basically universal. Anything that needs sourcing of reliable data can use these systems. And I guess that's where the domain of cryptocurrency goes beyond just its own domain, and whomever is interested in cryptocurrency can look into the Web3, but it's really going to benefit or have a societal impact on how we could train more things, and how we could also get out of this web of just getting our own generated data back to us all the time. And that's, I think, is super helpful, because this problem of synthetic data over dominating many things is for real. It's happening, and we really need to be cautious of that.
How can we be cautious as like a everyday user? So the non-technical person, the one who's using just like ChatGPT, who's using any of these systems, who's using, maybe he's a little bit into crypto gaming, likes to render some images, I don't really know. But how can, like, speaking to that everyday person who's just at surface level of the technical difficulties or the technicalities of all these systems, what should we be aware of?
I guess it's really hard to say. Some of the things are not not everything is like it's actually good to I guess this is a discussion I've recently had, because there was a recent Nature paper that was talking about this type of self-poisoning using synthetically generated data attack by actually my late professor of security, Ross Anderson, and others. But the problem is, I think, a little bit cynically addressed in what they have viewed, because what they're saying is that they're assuming whatever has been generated is just blindly fed back to what is being trained. But in reality, things that are getting generated, they go through a little bit of a check. For example, if you write a code and you use Copilot or any of these other generative tools to write your code, you're going to have some self-supervision by whomever is writing the code to correct some of the issues. Or if you're writing text, you may use ChatGPT, but there's some sort of a feedback. It's not as high volume as the data that we are generating, because I assume there will be a lot of bogus data being generated, because these models can generate a lot. But I think there's also some sort of a feedback that goes in the system that actually is helpful, because there is some human in the loop still. And the same is true for applications in, for example, smart contracts. Abnormal behavior will be somehow caught one way or the other. Things don't really go south all the time. There is some, as I say, some sort of a feedback. It's a low bandwidth feedback, but it is helpful for correction. And I think, the use of the Web3 confidentiality verifying technologies that Ari was saying could actually also help with providing these anchors that can be used for either checking if things are correct, or trying to just generate tests of this phenomenon. Ari, do you have something to add?
No, I agree with that. And in fact, it may be possible to do some interesting things like constrain the types of queries that can be sent to models, right? If you want to limit opportunities for adversaries to send adversarial examples to generative models, perhaps you require that their queries be formulated using authenticated data, and then you give them a lot less margin for maneuver. Now, of course, this is just a heuristic approach to the problem of adversarial examples. And as I said, that problem is a largely intractable one, but this may give us a slight leg up when it comes to dealing with a problem that we otherwise don't know how to address, and certainly don't know how to address in a principled way. So indeed, these Web3 technologies may enable us to address some fundamental problems that the AI community itself doesn't know how to grapple with, at least in isolation.
Yeah, and I think, Ari, you mentioned content signing, the C2PA initiative, which is basically a combination of camera, phone manufacturers, Adobe for transformation tools, et cetera, seeks to really take the concepts of provenance and add that to digital media. That's something that's actually means you're dealing with the entire pipeline of content, generated content, that obviously would take a long time to get adopted. But in very point examples, for example, whitehouse.gov, they're already using this, right, with their own media. And they're doing that so that they have provenance associated with that media, and that you know whether something came from whitehouse.gov versus it being synthetic. On the sort of generic consumer side, you have to think about browsers and content that shows up in browsers. Google and Microsoft and others have committed to labeling synthetic content if they can understand it is synthetic content in the browser. And so we'll see more of that. I wrote an article actually in CoinDesk a number of years ago that was specifically about the information overload that consumers experience, which way before generative AI was already starting to cause people to fall for different types of scams very easily. It is way easier now to generate fake content of all types, both text, images, and video. And I think consumers have to be much more diligent now than just a few years ago to avoid falling into various traps. I myself sometimes find, I'm looking at like advertising content and I see imagery and I'm like, this is clearly an AI generated image of a person, right? That keeps showing up in that. And, that's being done for a financial reason, right? Which is it's cheaper because they're not paying for stock imagery. And or it might even be faster in the production because they can just generate those images. So there's reasons behind it, but we're definitely living in a world where consumers are going to be faced with a higher and higher percentage of some form of AI generated content, and just starting to be really aware of that. That's a thing I think is really important for consumers.
And I do worry personally that purely technical approaches to verifying provenance can backfire. If, for instance, users come to believe that an image signed by a high-end Nikon camera is necessarily authentic, and somebody manages to extract the signing key from a camera, and there's every reason to believe that a well-resourced adversary can do this, right? We've seen plenty of key extraction attacks mounted against Intel SGX and a whole host of other forms of secure hardware, right?
Yeah, there was just an example, I don't know if you saw that, on Intel SGX being able to recreate the root keys.
Yes, I did. Yes, right. And that's one of just a litany of attacks against Intel SGX, of course. So trusted hardware in most cases can be trusted, but even if it can't be trusted 0.1% of the time, that creates real opportunities for mischief. And if people are not aware of these opportunities, and these opportunities additionally are exploited infrequently, then the risk of deception is greatly amplified. So I think we need to have multi-layered systems and institutions for dealing with deceptive content. I don't think pure technical solutions alone are going to suffice. Right? There are other issues like the context in which a piece of content is presented. Even if a photo is authentic, if it's presented in a deceptive context, then it may lead to the creation of deceptive content that can sway opinions in harmful ways. So these are complicated problems.
Is there any way that AI, this might sound like a silly question, but is there any way that AI can fix those problems? You're on mute, Farinaz.
Mute. I think there is a fundamental issue with AI, and that is AI. What it does is there is a huge dimensional space of data, and AI aims to compact it in a much lower dimensional space. And what happens is that there's a lot of projections of that high dimensional space into that lower dimensional space, and regardless of what you do, you're going to lose some of the data. And depending on how you constrain your model to learn that high dimensional space, what you project into and the lower dimensional space that you learn is different. And no matter what you do, because this is not a one-to-one mapping between the real world and the AI model, there will be these gray zones that will happen because the models are, and as time goes by, we can try to learn some of the data that is missing at the boundaries, which is, I guess the main reason for the adversarial samples or, the exploits. But of course, this is also very context related, because if you tell your AI model to be trained in a certain way with a certain objective function and do this mapping with certain amount of parameters in each of the layers, this model approximation format kind of changes. And that's kind of an inherent problem that we are seeing. So no matter what you do, there's always going to be loss of information from that higher level to that lower dimensional space. And the way you constrain it using the format you gave to AI is going to kind of impact that. And the more we check it, the more we use the models for the use cases, the more robust we can make it. And you can of course constrain it. You could try to smooth it out so these boundaries of uncertainty get smoothed out, which is like some of the methods people use for mitigating this type of problems. But the problems are fundamentally not fixable at the root because of this gray zone that we are seing.
Yeah. Sorry, go ahead.
I think I think you're largely referring to generative AI, I assume, when you talk about.
I think we lost.
Is that an accurate statement or no?
Sorry, your voice got broken. I didn't hear what you said.
Yeah, could you repeat that?
No, I sorry about that. I must have had some drop in coverage here. I was thinking we're speaking very generally about AI, and AI's many different things. So I was assuming that when you were talking about the gray zones, you're talking about the generative models specifically.
I was talking about any AI model that is compacting a model from real world data into a smaller model, generative AI models included.
Yeah. Okay.
Right, so.
Yeah, I was going to add, and then I'll let you go, Ari. Just as a data point, we're already using AI to enhance cybersecurity incident resolution, as an example, and it's a really, really big enhancement in terms of time to resolution to determine whether something is an attack or not. And why is that? That's because there's a lot of data. It's very hard for human beings to quickly correlate and sort of decide whether this looks like an attack pattern. So that's a great example of where AI is enhancing some bad actor activity.
I mean, AI, like all new or newish or newly useful technologies, is dual use. It's useful for attackers. It's useful also for defenders. And so we always end up with some kind of equilibrium. But I was going to remark that it's always tempting. There is a temptation to try to use AI tools to address the limitations of other AI tools. For example, if there's the risk that an LLM hallucinates, you might think that you take a different LLM and use it to vet the output of the first one, right? So you might check the output of Phi using GPT. But the problem is that adversarial examples actually transfer pretty well among different LLMs. So this approach in general is a pretty fragile one. And in general, the attempts to remedy the defects in one model by using another doesn't work very well in practice.
I'd love to touch on the idea of resource constraints when it comes to AI computing. We all know that, big tech companies spend a lot of money on data centers. We've seen actually Bitcoin miners start to pivot some of their operations or start to sell some of their energy towards AI computing. Does crypto AI have any sort of play in the solution or solving the issue of resource constraints, or figuring out a way to sort of align the incentives of energy companies and big tech and sort of use these big data centers in a way that sort of, I want to say, optimizes the use of energy, especially as the conversation surrounding the use of energy continues to flare up. There's a lot of questions about whether we should be pointing resources towards AI or not, what the dangers of those are. Bitcoin mining is a completely controversial subject in and of itself that I won't touch on here unless it's part of one of your guys' answers. But does crypto AI have any sort of play in resource constraints and the use of these and how we're allocating those to computing and to these LLMs?
Yeah, I'll answer sort of from a cloud perspective. Generally, clouds are resource constrained, right? And so the optimization game in cloud is, how do I best make use of those resources? And that's forever, right? Basically, well before AI. And so what's happening in the AI space, and why I always say that we're talking about it very generically. People are optimizing how to deal with AI workloads first, right? And for example, a great example of that is, do I need the power of GPT 4.5 to answer a specific chat GPT query, or can I use some other lesser algorithm, right? And that's a very simple example. But what people are starting to do is look at the whole optimization sort of workflow of, how do I break down a problem to make it more efficient, similar to how we build tech stacks. And so that's a prevalent area of resource optimization, just reducing the load of AI queries, essentially, as an example. So that's happening, everywhere, right? In terms of people's usage of AI workloads. And then secondly, the small language models that can rival the capabilities can be used in cloud, and it can also be used at the edge. And so we see edge devices, whether it's laptops that have a natural language processor on them, being able to offload some cloud workloads, for example, or mobile devices being able to process small language models that can deal with local data. Those are all very positive. And then that starts to lead into decentralizing AI workloads as well, which is something that might be incentivized through cryptography or other incentive mechanisms.
Interesting. We're running up on time. This has been brilliant. I'm sure the 800 plus listeners have been getting a lot of things to think about and clarifying ideas. And I'd love to open the table to just like some final comments. If there's anything that you want to leave us thinking about, or anything that whether Ari, Farinaz, or Yorke, that we haven't spoken about that you think is important, whether that's from a technical standpoint, whether from a non-technical standpoint, or something, yeah, some food for thought to close this roundtable off?
Well, I think one thing we haven't talked much about is the kind of Web3 ideological perspective on AI, which is that this is a power that, with apologies to Yorke, shouldn't reside in the hands of mega corporations, and that Web3 can serve as a decentralizing force, enabling communities to come together, pool resources to do things like train new models, create new cloud resources, and so on and so forth. I just want to remark that that's something we haven't talked about today, but that's an important theme in the intersection of crypto and AI.
In that vein, have you, because I think this is a really interesting topic, and it was on the list of questions or topics to ask today, but are there any projects or anything that you're seeing along those lines? I know that Venice AI is a sort of open source, private sort of ChatGPT alternative. But yeah, are there, for the people that might be interested in sort of pooling resources, getting involved in this sort of decentralized open source crypto AI intersection, or is there anywhere they can look? Is there any way they can get involved? Is there any way that anything that they should be aware of?
I mean, there are a whole bunch of projects.
Not saying that any that you say is a direct endorsement, but just to point somebody in some direction.
No, I mean, I don't want to endorse any one project. I will say that I do think that trusted execution environments are going to be a critical piece of this vision. I see them as really the only practical way, despite their many shortcomings, to achieve trustworthy decentralization of AI-oriented cloud resources. So I'll just make that very generic statement and leave it at that.
Yeah, and I guess as a professor, I'll make another very generic statement, and that is there is a lot of exciting opportunities at the intersection. So I think, whomever is looking into that, they will not go wrong. There are many different opportunities and many exciting problems to work on.
Awesome.
Yeah, I completely agree with those statements. I'll say what I said in the beginning. We're living in the read, write, own, infer era. And that if you're ignoring any of those things, you're doing yourself a disservice and your business a disservice. I mean, it's just a huge opportunity going forward.
Well, Ari, Farinaz, Yorke, thank you so much for the time. This has been really interesting, really fascinating. And yeah, to everybody tuning in, thanks as well for your time. So yeah, have a good one, everyone. Take care.
Thank you.
Thanks very much.
Thank you.